Good afternoon, ladies and gentlemen. So today's webinar, we are expecting more people to join in. So we could give them some 2 minutes to join in. But anyhow, the topic for today, you can see it on the screen now. It's about the integration between two products, between SMA and MyPV, and how you can optimize your self-consumption. So from my side, my name is Talal, and I will be your moderator throughout the webinar today. And at the end of the webinar, you will get the slides as well. So all the technical stuff, data sheets, you can get with that as well. So in this webinar, we will start with introduction, how my PV is, what my PV is, what our focus is for the customers who don't know my PV. And likewise, we will get to know about SMA products, how they are doing in the market, what they have it, and what products, how to integrate their products with my PV. So I guess let's start slowly and slowly. So as a part of introduction, my PV is a strong team with our director, Dr. Gerhard, from the left side. He is so-called the brainchild for my PV with his extensive experience from manufacturing of the inverters, solar thermal, and now it's being with my PV. In the middle, we have our international sales director, Dr. Alice. She is also in the chat. So if you have any questions, feel free to write it down. If it's my PV, either me or Alice will help you in. From SMA, it's Priscilla. So later she will have a part from it. And from my side, you already know the name. So I'm handling the international sales, let's say on the technical side. My background is an electrical engineer, so hands on to the electrical things. In terms of history of my PV, so it's a relatively young company. We started from 2011 as a distributor, but over the years, we completely turned into a manufacturing company. And since 2013, we have launched different products into the market, ranging from DC products to the AC products, single phase, three phase, and also we have grown into the Australian market as well. So the company itself is based in Austria. So we are situated in the province of Upper Austria. Who knows where where Upper Austria is? So we are just close to Linz, to be exact, or to the Wells. And our production facility is also in the neighboring building, which you can see on the right side. And this is our office building. So all the manufacturing, all the R&D is done in the Austria. So the products are made in Austria. So that's a sign where we emphasize on the quality. So going further, I will just leave it to Priscilla. Priscilla, now it's your part for introduction. It's towards you.
Okay, thank you, Talal. Hi, everyone. My name is Priscilla. So I'm the application engineer in SMA Australia. So me with my team. So I have Dean in this webinar as well. He's the application manager. So we are mainly handling the pre-sales inquiry, including your product compatibility, design issue, and also the integration with the third party. And for instance, for my PV. And SMA has been in the industry for 40 years, and we start in Australia at the 2007. And just a profile for SMA Australia, we are ranked 10 for the Sustainable Corporation for 2024, and it's not just in the renewable sector, but it's in the whole industries all over the world. And we have over 100 gigawatt installed SMA inverter power, And 35% of Australia's solar electricity is produced by SMA inverters. And in Australia, we have more than 100 employees. And since we are more talking about my PV integration, so it's mainly for the residential products, and they are compatible with our SMA Home Manager and SMA Energy Meter for the on-grid, and also compatible with the off-grid system, which is with the Sunny Island. Which I'll talk about this later on, and I'll hand over this webinar to Talal.
Thank you. I guess you can hear me. Just confirm. Yes. Okay. I gotta go ahead. So thank you for your introduction, Priscilla. So moving forward, what will we discuss and what things we do? So as I said, my PV is a manufacturer that focuses heating from the PV. So as you already know, you can do different things from the PV. For example, you can do EV charging and house load that are well known already. But the other sector which needs more awareness is heating. So as I said, our focus is heating, and what we say is you can, aside from house loads and EV charging, you can do domestic hot water and as well as electrical space heating. So as we go deep into the webinar, I will explain how these things are possible with my PV products. So, sorry, one slide back. So in terms of what our focus is, what we do in our AC products, you have a PV system. So you have just panels on your rooftop, and then you have a inverter, and from the inverter you get the AC power at house. So you are using that AC power at the house, and there comes a time when you have excess power. There's a surplus power. So what we do is just like a battery storage. If there's a battery that stores excess power, or excess power goes to the grid, rather sending that excess power to the grid, we divert that excess power for heating reasons. So this is a general approach. Okay, what we are doing is, so we are improving the self-consumption of the PV system. So generally, when it comes to self-consumption, you think about, okay, what are the options? So the one thing which clicks into your mind is the battery storage. So if you take a typical battery system of 5 kilowatt, you can see, or you can analyze that the per kilowatt price is still very high compared to a 300-liter boiler or a geyser. You can store more amount of energy in a hot water tank compared to battery storage with less investment. So still battery capital cost is quite high compared to a thermal storage. But anyhow, our systems can also be combined with battery storage system. It's not competition with the batteries, but rather we are saying, okay, you can see other modes where you can store excess amount of your energy with less investment. So in this webinar, as I said, we will focus the products which integrate with SMA, but as just a background, what our products are. So we have DC products which just directly connect with the PV panels, and they use PV power directly for the heating reasons, but that we will be discussing in some other webinars. And then we have AC products, which is ACL2, but that's not available in the Australian market, so that we just skip it. And the products, for example, AC Thor and AC Thor 9S are solar power diverters that work on grid and off grid with SMA system on the AC side of the systems. So how this stuff works with SMA, what things are being you need to consider, we will be discussing at the in the webinar. So in terms of integration with SMA, as Priscilla said, that there's a on-grid compatibility and as well as off-grid compatibility. So further in on-grid, we have two types of possibilities. One is with SMA Home Manager. So here you have a direct visualization of my PV products in a Sunny portal, and then there's a SMA direct meter communication. So there are these two possibilities for the customer, which I will explain in the next slide, but just an overview, there are two possibilities in the on-grid scenario. In the off-grid scenario, it's based with the Sunny Island with the frequency shift, and that's the possibility. It detects that frequency change, and my PV product, the AC Tor, reacts to that change. But anyhow, that's just an introduction. I will explain it how these things really work with the on-grid scenario. So in the on-grid scenario, I already mentioned that there are two possibilities, starting with the SMA Home Manager. So in this case, SMA is the master of the system. So we are not the controller. We are just reacting to that information, how much excess power is available. So you just control the settings through the Sunny portal, which Priscilla will show you in the part of SMA. The complete control, the complete prioritization of battery charging, and hot water. So you can do all these prioritization through SMA Home Manager. And then comes the SMA direct meter communication. So as from the name, it quite clear that we are here the master of the system, and we get the excess power information, how much excess power is there, and we do both as a controller and as well as a power regulator. So here you cannot visualize my PV product in SMA Sunny portal, but rather you need to use our if you need to visualize the system for in case of SMA direct meter communication. So what can be the reasons to have a system like my PV? One is the energy independence. So you are away from the gas, from the fossil fuel, as already in the Victorian region, there are regulations coming up that you cannot use fossil fuel, or the system has to be electrical based heating. So that's a way to get energy independence. You don't need a source from the grid side or any other source. Other can be a low feed-in tariff. So in the past, grid was being used as a battery, but now feed-in tariffs are being placed, or there are zero feed-in, which doesn't allow you to export excess power to the grid. So that can be the reasons, because hot water doesn't cost you anything once it starts diverting the excess power. Other reasons, yeah, the grid stability, because more and more PV power is getting into the public grid, that causes more issues with the grid. So that's one thing to improve the self-consumption and further reasons. So we have done some analysis on how it looks like with the PV self-consumption. So it's a third-party data. It's not our data. It's from the Berlin University. So with the self-consumption, with the typical on-grid system, let's say, or off-grid system where you don't have an off-grid, of course you have a battery, but considering a system without a battery, with the typical single-family home, let's take 5-kilowatt system, your self-consumption is roughly 30%. But anyhow, you can, as we said, add a battery and go up to 70%. But the drawback is that your self-consumption will be at a huge capital cost, and still that's the case. But more effectively, you can go up to 80%, such a solution from MyPV with the solar power diverter. You can go up to 80% with less investment. But as I said, we are not directly competing with the battery. Both systems can be combined, and you can go up to as high as above 90% of self-consumption. So there are different options which you can try out and improve your self-consumption. So how our system works with the battery storage. What we tell our customers is that, yes, it makes sense to prioritize the battery first, because what you put into the battery, you can get back that. But in case of hot water, still there's no signs that you can bring back the energy. So in a typical day chart curve of the PV, till noon, your battery charge is full, and after the noon, it starts diverting that power to your thermal storage, to your boiler, or to your geyser, etc. So in terms of how the system works with the SMA, there's, as I said, you can visualize in SMA Sunny portal. So in a day chart curve, what I would like to explain here is that there are these parameters. For example, the gray one is the fixed load from the house, and here the green one is the chart where we are diverting for the hot water storage. So it's being used by MyPV, which you can visualize in the Sunny portal. And the system is with the battery storage. The 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 orange shows the battery charging. So you can see in the roughly at 8 a.m. the battery starts charging, and till noon the battery charge is full. So it goes down, the battery is full, so there's no place for the battery for excess power, and simultaneously the charging for your thermal storage from hot water diversion starts rising. So that's go up, and as the day goes by, it stores all the hot water storage into your boiler. And likewise, it follows up to the yellow is the PV production. So it follows as much as PV excess is available, it diverts that excess power to your hot water storage. So that's about how it reacts with the battery storage system. So in terms of our products, which I guess you already know the background, how it works, what things are. So we have two products that are available in the Australian market. One is the AC Thor, the single phase unit, and then we have a 3-phase unit, which works with 9 kilowatt of linear power control. So one thing I would like to highlight, because there are a lot of competition in the market in terms of solar power diverters, and there are different options available. For us, which is important, is that our products are working on a linear power control with PWM. So that's really important for the grid, that it doesn't cause any distortions or that, and we are diverting every watt which is excess power. So we are reading the excess power information 1 time per second, and that's really, really fast. So coming to the product side, as I said, on the left side is the single phase unit, which is doing a linear power control from 0 to 3.6 kilowatts. So 1 second there can be 200 watt, the other second it can jump to 1000 watts. So as PV power is continuously changing, we are reacting to that. So everything is plugged. You don't need to open the terminal box or anything. So everything is plugged in. The temperature sensor is plugged to it. So you get one temperature sensor in it. The communication, there are two types availability, but with the SMA it works over the Modbus TCP. So that's the communication type with SMA. And then there is you can connect up to 4 temperature sensors, and further on the right side you have a relay contact as well for any secondary or auxiliary load you wanted to switch. That can be heat pump, that can be resistance, which I will further highlight just into the coming slides. So moving to the right, we have a three-phase unit. Most Australian market is single phase, but let's say for the commercial scale, for hospitals, for agriculture application, there's an option with ACTOR 9S where you can regulate each phase of 3 kilowatt. So there are 3 outputs, each with 3 kilowatt. And just like the single phase unit, it has all the standard communication, Modbus TCP, Modbus RTU, and further relay contact. So some of the technical details I have already mentioned, but you will get the slides anyway from us, and you can dig deep with the data sheet, operation manuals. But just to highlight that ACTOR has a display, a touch screen, very intuitive touch screen, but also includes a web interface where you can do more settings, and there's a cloud integration possibility as well. So you can do remotely the settings and as well. So the installer doesn't need to be on the site. Rather, our support or your installer can just fix it remotely if every hardware is just correctly installed there. With the load connection, you can connect any resistive load with the ACTOR, so it's not necessary to use MyPV's immersion heater, but rather any load which is of ohmic or resistance, you can connect it with the ACTOR. Yeah, in terms of ACTOR 9S, there's a more higher power options. It goes up to 9 kilowatt, as I said. The important is that it needs a star connection, so a connection with the neutral. So neutral is necessary to have ACTOR 9S, and that's important for the functioning of the unit. Otherwise, it's a no-go. Yeah, in terms of application, there are options as a mode 1 in terms of most commonly used for domestic hot water. So that's the most general application. And then there's different modes depending upon your application, what the project is. So is it with the heat pump? So you can do the switching. Space heating makes more sense for the passive house. Let's say low energy buildings where you can regulate the electrical space heating mats, the infrared panel. So those are the applications which are possible in both ways in mode 5. Yeah, again, if you have a project, feel free to discuss how we can do it. But as an overview, how it looks like in terms of application. So here's a standard way. For example, you have PV panels, and then you have a SMA inverter. In this case, there's a battery storage, and I'm talking about an on-grid scenario here, and there's a meter at the feed-in point. So that meter at the feed-in point sends information to the inverter, to the SMA inverter, and from the inverter we are communicating via Modbus TCP through networking. There's no direct communication, I mean not direct Modbus cable, but rather a router networking, and through this we are getting the power information, because there's a balance that is continuously changing. Somebody's turning on lights in the house, or there can be cloud on the horizon, so everything in terms of balance is continuously changing, and we are reacting to that information. So whatever power is going to the grid, we take that to the hot water storage in terms of thermal storage. So here's a screenshot from the EC-Tor display, our solar power diverter. In this case, it's a three-phase, and you can see here it's diverting roughly 1800 watts of excess power. So you can monitor different temperatures in the boiler. So here you can see, okay, at top there's 59, 45, and then on the bottom it's 23. So you can monitor it as on your display, or on the cloud, or on the web interface. Yeah, this operating mode 5, which is with the both possibilities in terms of hot water and space heating. So here I need to explain a bit, because this type of system only makes sense, let's say, in a passive house, low energy houses. So if you have an old house where space heating demand is very high, that's unfortunately not possible with the PV power. But in a low energy houses where you have low demand for space heating, it's possible with PV. What happens is that you have same system panels, inverter, but here on the output side, you are regulating temperatures in the different places. For example, in the boiler, it's the standard immersion heater that's being controlled up to whatever temperature target you have, for example, 60 or whatever. And then there's a other resistive load in the room, for example, electrical space heating mats, in other places infrared panels. So we can do simultaneously regulation for the temperatures in different areas. Even on the screen you can see, okay, in the boiler it's 45-degree. In the room, of course, there's a low temperature demand, so you can set that. You can prioritize the excess power. For example, there are three outputs, as I said, with AC-Tor 9S. You can prioritize, okay, room temperature please first, and then the boiler. So you can always play that with the settings that are on the screen or on the cloud. Again, a schematic how it looks like with the AC-Tor 9S. Here it's without the energy storage, and but still controlled by the SMA Home Manager. But just to have your understanding what's how it looks like, the gray again is the base load. Then the blue part is a solar power diverter being used for heating reasons. So as soon as you can see, okay, PV production is going up and there's enough excess power, it starts using that power for the heating. So it goes as there's PV power is going up and down, so it's just reacting to that very quickly, very fast. And after the afternoon, when there's no more excess power, it simply shuts off the power supply to the hot water storage. But just one thing keeping in mind is that by default it's using only excess power for heating, but you can turn on the backup power. So it can also use power from the grid. So during afternoon, during night, when you need power from the grid, you can use that as well for heating. But by default, it's off, because it makes more sense to use PV for the heating. And during afternoon, if there's a need, you can use power from the grid. Some more things on the technical side. Yes, you can connect multiple devices together. So if you are using our system, you can connect up to 11 devices together. With SMA, you can connect up to 6 multiple devices together. And yes, again, most focus is residential market, but as with 9 kilowatt or three-phase system, you can go up to commercial scales, which I will also explain in the coming slides. So we have our own tool as well. So the link is integrated in the slides, but you can visit our homepage. So this tool is recommended for consultation. This tool is recommended for end consumer, for your consultants. What this tool does, it gives you a rough estimation. So you can put your PV parameters, how big is your PV, the feed-in tariff, the electricity tariff, how big is your boiler, your tank, is there battery storage, the gas tariff, how many people are there. So all these parameters you can put there. There are different locations available from Australia. So when you put that, you can get an rough estimation what products you will need from MyPV, how much savings would look like. So you can compare it with conventional system and with MyPV, and then you can compare the cost. You can get the payback period. Okay, with these calculation, you can easily uh, estimate the systems and gives you a feeling what things look like. It's a free of cost tool. You don't need to pay it. You can just go on the website and just play with it. So now the interesting part with the AC Tour in terms of off-grid. So in off-grid, I will just go on the next slide. So what happens is in the off-grid, so there's no direct communication with the SMA. For example, there's no Modbus communication or anything like that. Rather, what happens is those who know off-grid that there's a PV system, PV inverter, and then you have a battery inverter. So you have these two systems and you create a microgrid with a frequency. So there's no standard, let's say, grid frequency, as you have 50 hertz or 60 hertz depending upon your region. But here in this case, once you have a battery inverter, that creates your microgrid. And what happens is that once this battery charge is full, it sends a signal to your PV inverter that, hey, I'm about to full. It increases its frequency a bit. You can set 2 frames of the frequency. But coming back to this point, once the battery is full, it sends a signal to your PV inverter that, hey, I'm about to full, and you need to shut down your PV inverter. But we detect that frequency shift and we react to that frequency change, and we start diverting that excess power to the heating application. So otherwise, PV inverter would have shut down and this power would have been not generated. Rather, from preventing it from shutting down, we start to generate that uh, power for heating application. So there are different applications to that. We have an agriculture farm in Australia, in Western Australia, where they clean up the fruits. They need a hot water for that, and they generate hot water for heating applications. Then we have also some of the plants in Antarctic, where they have a Belgium research center. So it's running combined with the wind power, where it works with the as the dump loader with wind power, and as well as with the PV inverters, it's working as a thermal storage where they use ice to melt and use it for drinking purposes. So, some of examples how people have already done it in the Australian market. So, one example where you have more colder region, you have more, let's say, temperature delta. It's in Tasmania. The user had a 3.5 kilowatt system with a 300, roughly 300 liter hot water storage with 3 kilowatt of immersion heater. It's simply working on off-grid system with the Sunny Island. There are 3 person in the house, and it's working with the 12 kilowatt system. So according to the estimates made, that there had been 70 kilowatts of the PV power being used for hot water diversion. Otherwise, that would have been not used, and it would simply be used by AC Thor for heating application. Yeah, I guess from my side, that's all about my PV and SMA system. If you have any questions, just feel free to write it in the chat, and just I will hand over to the Priscilla. So Priscilla, looking forward to you. It's up to you now. See you at the end then.
Yeah, thank you. Okay, so what has been mentioned by Talal before, if you want to get the home manager or Sunny Portal as the controller of the My PV system, then you need to get the home manager. So in the home manager, as everyone knows, it can be registered on the both Sunny Classic portal and also in our new portal NXOS. However, for the Sunny Home Manager act as the energy management system, you need to register the system all in the Sunny Classic. Okay, so prior to adding any My PV device, you need to first of all register your Sunny Home Manager with your inverters, and you can add the My PV device from the configuration, and you can go to the device overview. Afterwards, you can add a new device, and it will detect the devices, and it will detect as the smart appliances. Then you can click add. And afterwards it will show um, the settings, like just the default settings of the smart appliances. So the first settings that you will have is the priority of the load. So you can choose it to be a very low priority or the very high priority. And for the optimal energy demand, as we know, if you plan to get your excess PV to prioritize all of the heating, then you will need to select the proportion of the PV energy. And afterwards, you can click next, and it will just show you as a summary, and you can click finish. So it's just as simple as that for you to add the load or the smart appliances of my PV device onto the home manager. And afterwards, if you go to your configuration and go to the load overview, and you can see what is the load type is it, and you can see what direct communication and what is the status and so on. And for the Sunny Home Manager, for the tips and tricks, so for the proportion of the PV energy, you can choose how many percent you want it to get from the external energy supply. So external energy supply is imported from the grid, and you can also select PV power generation 80%. So if you just want to get excess power only to generate energy to the my PV device, then you should put it as 100% and this as 0%. However, if you choose to get several percentage from the grid, then you can put it as a 20%. And we have another settings called surplus PV energy. So as I mentioned here, the surplus PV energy will be only activated if you have set the export limitation on the Sunny Home Manager. Like say you have put export limitation of 5%, then you have 5 kilowatts, sorry, and you have 3 kilowatt load. and you will only have 2% to be exported to the grid. So, like, say, if you want to get more than 5% of your export limitation, you can set this to increase the power generation from the inverter to generate the energy to the heating. And you can also prioritize if you want to get the battery fully charged first or not. So, usually people will set priority to the battery first. Okay, and that's just for the on-grid. And for the off-grid, as mentioned by Talal, there's no special settings required on the Sunny Island because all of them are communicating via the frequency shift power control, and you just need to connect the MyPV device into the AC one of the Sunny Island and act as the load. And as mentioned by Talal, the MyPV device will detect the frequency shift, and this is what it will look like in the just a typical off-grid system from our Sunny Portal um, Analysis Pro. So you can see in this blue color, it's usually the PV production. Usually, if the full sunny day, it will show like a nice bell curve. However, because this is the off-grid system, once the battery full, once the battery is full, then you can see it directly dropped by increasing the frequency. So previously it's 50 hertz, which is a normal um, grid frequency. But once it is full, the battery is full, then it will increase the frequency of the sunny element and it will ramp down the production. However, if you have my PV device and you set it as the off-grid system, well, it will detect the frequency shift done by the sunny island and it will start to generating the power and uh, export the energy to the my PV device, and you will see the smooth bell curve again while the excess of this power are generated to the my PV device. That's
Okay, let's end the webinar for today. So in terms of information from my PV products, you can find the all the details how to integrate with SMA on our homepage, the data sheets, the webinar records, the wiring diagrams. All this stuff can be found on our website. There's no special login needed. It's free. Everything is just there. You just need to click it and that's there. Yeah, just a glimpse what our system helps is that it's really easy for the customer. Once it's installed, it's just there. You get hot water in summer for free. There's no additional cost. You can turn off your primary source of heater from, let's say, from spring to autumn and completely rely on my PV. That saves your cost for heating plus the lifespan of your primary source of heating. So you can make that longer for your systems. And yes, you can contact us through our uh, contact form, which is available on our website. It's for supporting private customers if they have installation issues, or the installers, so we can just help them via email or whatever issues are. If your device is not working, we can check that remotely, so the installer doesn't need to be on the site. So that's a small thing. So we are at the end of the webinar. So if you have any questions, there's still time to put that in the chat box. From my side and Priscilla, we will do our best to get back to those questions. But anyhow, everything comes to an end. So really thank you for taking the time and getting in touch with my PV and SMA. And likely thank you or special thanks to Dean and Priscilla for taking the time and discussing what things are possible with the SMA system. Have a nice evening. Stay safe and enjoy your evenings.
Empowering the solar future.